Okay, functions are a relationship between the input and output values. So you're going to be analyzing the relationship between the x and the y. So a function can actually look in different ways, in different forms. So in the first one that we have is y equals 2x plus 1. Whenever you see an equation like this, you know that this will be a function. Now, we also have a table where you have an x value that goes straight into a y value. So we have -1 that gives you -1, 0 gives you 1, 1 gives you 3, 2 gives you 5. So there's only one input that goes to one output. If you have an input that goes to two different numbers, that will not be a function. Now, the next example is a diagram or a map. One more time. -1 goes to -1, 0 goes to 1, 1 goes to 3, and 2 goes to 5. That still works as a function because there's only one input for every output. And the last one is a graph. Whenever you have a graph, you just need to make sure that you can do a vertical line and it would actually only touch one point. We'll get into that later on. For this part, you actually have the same equation, the same function that actually is connected to another 3 different forms. So this equation looks like this in a graph. Also, those are the numbers in the table and how it would look in a diagram. Now, we're going to determine when it is a function based only on an equation. So equations can look in different forms. So you have y equals 3x plus 1. This is an example of a linear equation in the form y equals mx plus b. Now, you also have other ones in the form y x plus y equals 1, and that is also a function. You could even have y equals 3 or y equals 0, and that will still give you a function. The main idea is that you need a y value. Another way to write a function is x plus 8 equals y. The order doesn't change, and even you will have examples where you will have x plus 1 equals y minus 2. This is another example of writing an equation that is a function. There are only a few cases where you will actually get an equation that is not a function. Let me show you one. For example, if you have x equals 1, in this case, this will not be a function because when you graph it, you will look like at 1, you will create a vertical line. Vertical lines are not functions. So whenever you have an x equals something, not a function. But if you have y equals 1 or y equals x plus 1 or x equals y minus 8, that will still be a function. To know if it's a function from a table, what you need to pay attention is to your x values. So you're going to only go and pay attention to your x values to make sure that one x value only has one precise output. Now, 1 goes to -8, 0 goes to 0, 3 goes to 4, 2 goes to -3, then you know for sure that you only have one output for every input. For the next one, for the next table, you see -2 goes to 3, that's fine. 2 goes to 3, that is totally fine. The outputs can be repeated, the inputs cannot be repeated. 0 goes to 0 and 1 goes to 1. So in this case, that's another example of a function. For the next one, you have 1 and -1 and 3, -1. Again, outputs can be repeated, that's fine. You have 1 goes to 0. So this will not be a function because you have two outputs, two inputs that repeat. So you have one that goes to -1 and one that goes to 0. So if you plug in 1 into an equation, you could actually have two different outcomes, so it wouldn't be a function. Now, to know if a graph is a function, you need to follow the vertical line test. So what we're going to do is draw a vertical line and see if it touches more than one point. In this case, we're going to draw a line here, but at that point, it only crosses once. If we try it here, it only crosses one. If we do it here, it only crosses one. So this will be an example of a function. Now, right to the next one. Once again, we're going to draw a line, a vertical line, and we see that it only touches once. Now we draw another vertical line here, and it only touches once. Even if we do it here, you can see that it only touches once, so it will be a function. For this one, we're going to draw a vertical line, and then you see that it touches here and here. That means that it has two different outputs, so not a function. Once again, if you draw a vertical line and it touches more than one point, it's not a function. Even though they're here, you can see that it may touch only one at some point. If at one point on the graph it touches more than one point, then it's not a function. Now here you have an example of a piecewise function. This is a function because if you pass a vertical line, it only touches this point because this point is open, so it would still follow the vertical line test. Now this is a cubic function, so if you draw a vertical line, it would only touch one point. So functions don't always have to be straight lines to be functions. The main thing is make sure that it doesn't touch 2 points on the graph when you do the vertical line. Now we're going to be paying attention to diagrams. For this one more time, the only thing you're going to be paying attention are your first numbers. So the first ones will be your x's or your inputs, and the second ones will be your y's. Now you look for 1 going to 1, that's fine. 0 goes to goes to 4, that's fine, and 3 goes to 2, that's fine. It doesn't matter if these lines are crossed as long as the input only goes to one number. Now the next one, it tells you 1 goes to 4, 2 goes to 4, 3 goes to 4. That is totally fine. They're having the same output, but the inputs don't have two different outputs. But look at the last one. The last one is not a function because 1 goes to 3, but 1 also goes to 9. So that means that one input has two different outputs. So by definition, that is not a function.